Let me present you a report on the topic the use of computer modeling in the educational process based on the example of studying Coulomb's law. Modeling can be used to study a variety of objects and processes, from climate change to the behavior of physical systems or economic phenomena. It allows us to analyze complex relationships and conduct research in conditions where real-world experiments would be difficult or dangerous. In education, computer modeling defines an activity-based approach to learning and development. Virtual laboratories, simulations, and interactive exercises provide an opportunity to create a realistic learning environment where students can experiment, solve problems, etc. In scientific studies, computer modeling plays a key role in solving various problems and studying complex systems. Modeling expands the possibilities of experiments, allowing the study of phenomena that would otherwise be difficult, costly, or impossible. Thus, the current position of computer modeling in scientific research demonstrates its key role in advancing knowledge and developing the scientific field. Implementation is performed using various tools. For this purpose, you can use a variety of instrumental software tools and environments: MathCAD, MATLAB, Maple, VisSim, Genius, etc. The advantage of using mathematical packages is that they can be used as ordinary calculation tools, tools for simplifying expressions, and tools for generating graphics and sounds. The means of interaction with the Internet, which are realized by generating HTML pages directly in the process of calculations, have also become widespread. A qualified user who knows at least one of the programming languages can create the required program or even a whole set of programs independently. However, this approach usually requires a lot of labor to program, debug, and test each program, so to save time, it is advisable to use the specified application software packages, the areas of application of which largely overlap. Use software packages for simulation modeling. Simulation modeling is a research method when the system under study is replaced by a model that can describe the real system with sufficient accuracy, and this model is used to conduct the necessary experiments, the purpose of which is to obtain information about the system. This type of modeling is used when it is not possible to experiment on a real object, build an analytical model, or create a simulation and track the behavior of the system in real time. This type of modeling is the most effective when designing and analyzing production systems, determining requirements for equipment and communication network protocols, modernizing various processes in the business field, etc. The most popular simulation modeling packages are shown on the screen. To make the review more substantive, let's define a topic from the school physics course, Coulomb's law. Simulators that can be used in school physics courses cover a significant amount of educational material. The most well-known collections include PhET, Lab Exchange, Concord, Praxilabs, Labster, Merlot, Physics at School Kit, and so on. For organizing and conducting e-learning and for self-education. The simulations presented here also include simulation for the topic we have chosen. It is clear that each simulation represents an appropriate methodological approach to the study of Coulomb's law. This can be demonstrated on physical devices or on imaginary objects. In any case, the choice of simulation depends on the prevailing teaching technology and the availability and accessibility of simulations for use. The analysis allows us to identify some intermediate results. The possibilities must include realism of the created models, interactivity and the availability to conduct such experiments, and flexibility of model parameter settings. Spreadsheet processors are not only a tool for calculating accounting spreadsheets. Spreadsheets are an excellent all-purpose tool for calculating, storing, and analyzing results. They are more suitable than any other application software as a platform for computer modeling. Spreadsheets are available both as desktop programs and as services. Popular spreadsheets today include Microsoft Excel, LibreOffice, Calc, OnlyOffice Spreadsheet Editor, WPS Spreadsheet, and others. The above examples are also available for mobile platforms. Among the cloud services, it is necessary to mention such resources as Google Sheets, Microsoft Excel Online, Zoho Sheet, OnlyOffice Spreadsheet Editor Online, and others. Most of them are available under free licenses or licenses with some restrictions. Thus, we can state that there is a significant list of available spreadsheet processors for secondary education, and the issue of their availability is not currently an issue. Of how spreadsheets can be used when studying Coulomb's law. First of all, we can show in practice what a direct relationship and inverse relationship are. To do this, it will be enough to calculate the value of the force of interaction between charges at constant values of charges and a variable part of the distance between them. Using the obtained values, we will construct a line graph and demonstrate that the graph will not be a line. Second, we can demonstrate whether the charges will attract or repel at different values. To enhance the visualization, we can use conditional formatting. Systems are as useful a tool for computer modeling as spreadsheets. The ability to store data, calculate various values, including through the use of programming elements, built-in functions and additional modules, make it possible to consider these systems as a full-fledged implementation of a computer model. The available data visualization tools and the absence of a workflow, which is surprisingly important for the research, indicate the advantages of computer algebra systems in modeling. The caveats include the need to master the systems at the level of a confident user, since each of them has its own specifics, set of commands, etc. The computer mathematics package, Scilab, is an excellent tool for conducting research that requires calculations. This package can be applied in our case. Despite the fact that the system, as already mentioned, requires some knowledge, its consideration is already included in the curriculum and relevant textbooks on computer science at the secondary level in Ukraine. We can define either a simple variant of calculating the value of the interaction force according to Coulomb's law, or a more complex variant for an array of values, and then experiment with the parameters. For academic freedom, each teacher is not prohibited from using not only different methodological approaches to teaching, but also the choice of teaching aids. It is clear that not every teacher will create their own implementations of the computer model, but this is a possibility and should be included in the comparison of computer modeling tools and methods in secondary education. To implement a computer model without using existing general and specific purpose application software, knowledge and experience in programming are required. Moreover, this experience should correlate with the student's programming experience, because it is one thing to demonstrate the created model when familiarizing the material in general, to provide students with the opportunity to experiment with the implemented computer model, including during self-education activities, is a completely different issue. If we look at our topic, Coulomb's law, we can create an application in Object Pascal that will calculate the value of the interaction force for the entered values of the charges and distances. In addition, we can plot the dependence of the interaction force on the distance between the charges. To visualize the interaction of the point electrostatic charges, power lines are usually drawn to show how the charges interact with each other. For such a visualization, one can also use the Python programming language using appropriate libraries or ready-made developments. To combine the analysis of the impact of the use of computer modeling tools on the results of educational activities with the analysis of the results themselves, which depend on the purpose of the educational process. These results depend mainly on the level of education and profile. To a certain extent, the results of studying physics at the level of general education, vocational, professional, pre-university and higher education are united by the fact that as a result a single physical picture of the world should be created, which is a prerequisite for the formation of scientific worldview. In addition, the structure of ideas about processes in the world around us is formed, which allows us to form technical thinking, which in turn helps us to adapt to the current pace of development of science and technology. However, depending on the chosen profile of the studies, the depth of such a technical outlook will vary. It is logical to conclude that the amount and depth of knowledge gained depends on the chosen future specialization, and this allows us to assert that the range of knowledge should range from the level of possession of information about how the world around us works to a complete understanding of all laws and processes with the ability to independently analyze and synthesize information and apply the acquired knowledge. Thus, the use of computer modeling tools should also correspond to these limit cases. We used the expert method to evaluate the considered modeling tools for studying the interaction between charged particles. We had two groups of experts, Donetsk, Khmelnytsky, and Odessa regions. The first group consisted of professors and teachers of physics, and the second group consisted of students and pupils. Physics teachers and professors and 72 students took part in the survey. The results of the survey are shown in Figure 8. The majority of teachers and lecturers agree that e-learning resources are a useful teaching tool. Teachers expect computer modeling to be interesting for students. Teachers agree that it is a useful method of both problem solving and cognition, but they are not willing to take the initiative to promote it themselves. For students, new things in physics class are always interesting, and therefore they are happy to use electronic educational resources. The majority of students agree that e-learning resources are useful for understanding the material. Only a third of the students perceive the computer modeling method as interesting and useful for learning, and only 6 students out of 72 are ready to continue self-educational research activities using the computer modeling method. It was almost identical in the opinion of both teachers and students. The highest rating was given to the off-the-shelf simulators because they are bright and ready to use. The lower rating was given to their own developments in programming languages because it's programming, so it's difficult. A comparative analysis of modeling tools has shown that mathematical packages are the most functional and convenient for use in educational process. At the same time, off-the-shelf simulations also provide opportunities for modeling, although they are not as versatile. General-purpose application software, in this case spreadsheets, is suitable for using modeling as a method of solving problems and improving research competence. Attention should also be paid to the use of programming languages in computer modeling, despite the fact that it is necessary to have appropriate programming competence. Thank you for attention.